Good morning, everyone. Yesterday, we just started the portion lightning arrestor. So we can continue the same. So we were discussing about the importance of lightning arrestor for a building, and today we will discuss about the requirement of lightning arrestor. By how can we calculate like what all things are required for the lightning arrestor protection, lightning protection system, like whether lightning protection is necessary or not. Okay, so based on Indian standard, we'll be doing the calculation. Calculation means you're just following the standards and there are some values. For example, according to the location, we have to take some thunderstorm days value given in the standard, and based on that we have to check and with the building height, length and width, and we need to check whether lightning is required or not, lightning protection is required or not. There are some factors to that we need to understand whether lightning protection is required or not. Okay, if lightning protection is required, then we need to calculate the number of down conductors and the air terminals and the earthing pits location, etc. Okay, so based on the Indian standard regarding the lightning protection, there's an important point. If you see the 27th point in this particular, this is a Kerala State Electricity Board handbook. So multi-story buildings is a topic. So in the category high-rise buildings, you can see 27th point. Lightning protection shall be provided for high-rise building as per IS 2309. Okay, then the next point is, or the sub point is, structure having a base area not exceeding 100 meters square need have only one down conductor. Okay, structure having base area not exceeding 100 meters square need have only one down conductor. And next point is, for structure having base area exceeding 100 meters square, the number of down conductors shall be smaller of the following. Okay, so if the building structure base area is exceeding the 100 meters square or 1000 square feet, you have to consider two important points. One plus additional one for each 300 meters square or part thereof in excess of the first 100 meters square. That means for the first 100 meters square, you have to reserve one down conductor. And after that, you need to take the additional square feet, like for each 300 meters square, you have to consider an additional down conductors. That means if you have 400 meter square building, you would need one down conductor for the first 100 meter square, and the remaining 300 meter square, one down conductor. Okay, so total two down conductors will be required. The down conductors means the down conductor is actually coming down from the building. So overall, the building you will be having what we say, the down conductors, either it is copper or GI. Okay, it will be laid along with the porcelain insulators. Okay, and this down conductor shall be brought down to the earth pitch. So how many number of down conductors required? It is actually based on the base area of the building. So that is the point. If the base area is having 100 less than 100 meters square, you need only one down conductor. If it is exceeding 100 meters square, you need one down conductor for the first 100 meters square. Then for each 300 meters square, you need an additional down conductor. Okay, that we can discuss while doing the calculation. And next point is one for each 20 meter of the perimeter. If the top surface is like a hemisphere, like a sphere, you can calculate the perimeter. Okay, so out of this, whichever one is smaller, you can take the down conductor based on that value, which means you are getting, considering the first point, you are getting 4 numbers, and considering the second point, that is for the perimeter calculation, you are getting 5 numbers. So out of both, you can take the smaller one. So you can take 4 down conductors. Okay, and copper or GI strips of 20 into 3 mm may be permitted for the lightning protection above ground level. Below ground level, minimum 32 into 6 strip shall be used. So that is the two important points, 27th and 28th. Okay, regarding the lightning protection systems, if it is required, you need to do this calculation. So to check whether it is required or not, you have to follow Indian standard. You have to check the particular value mentioned in that table, and you have to do a similar to like a calculation. So then we will understand whether lightning will feel like why do we need to do this calculation. You can directly visit the site and you can check the geographical conditions. You can get the local information. You can, from the client itself, he will be telling, yeah, this area is prone to lightning. Recently we, nearby our home, they had some damages because of the lightning. So then we can directly, don't need to do the calculation, directly you can provide the lightning also. But as per the standards, there is a calculation method and you have to follow if you're doing the particular calculation, or else you can directly give the lightning protection system, because as per the rule it is not mandatory, but for the protection and safety of your building you can provide lightning protection system. Okay, so as discussed yesterday, if our building is actually a single story building and you are having a multi-story building near to our building, then in that case lightning protection system might not be required, because that high-rise building must be having lightning protection system. So in that case our building will be having safety from the lightning. So and also don't think that all the electrical equipments in our building will be in a safer condition if you're providing lightning protection system. You can get the surge current also. You can get the surge current from the lightning through the electrical utility lines. Okay, so for the complete protection you need to provide lightning protection plus surge protective devices. Okay, so coming to the calculation part, that whether the lightning protection is required or not. Okay, so I'm taking the Indian standard IS 2309. So you can see a map indicating average number of thunderstorm days in the year. So you will not get all the city details. They have mentioned only major cities. Okay, so if you're taking a nearby city to that particular mentioned area, you can take the nearby value. Okay, that which means in, if you are taking Kerala, they have only 4 areas, equal intervals from the southern part to the northern part. Okay, okay, so here you can get the annual thunderstorm days. So why we are checking this annual thunderstorm days? We have to calculate the lightning flashes per kilometer square per year. Okay, to get the lightning flashes per kilometer square per year, we need to check this annual thunderstorm days. So from this particular value, for example, you can see if you take Kargil, there is only 2 days in a year, only 2 days there we have the thunderstorm days. Okay, and if you take Bangalore, you can see 45 days. So in a year, 45 days you'll be having thunderstorm days. Okay, so for that, to do the calculation, right? So first one is lightning flashes per kilometer square per year. So to understand this, you need to check the annual thunderstorm. This is actually mentioned in N suffix G. N suffix G. Okay, NG. So if you take Cochin, 63 days. So out of 1 year, you are having 63 days. It's a thunderstorm days. Okay, 63 annual thunderstorm days. Okay, so based on that value, you can see this particular table. Okay, thunderstorm days per year. You can see the number of days with thunderstorm mentioned in the left hand side, and you can see the limits and the mean value. Okay, so if you are having 63 days, you can take 80 days as the thunderstorm days from this table, 80 days. Okay. So if you're taking 80, the limit you can see 3 to 70. Either you can take any value between 3 to 70, maximum 17 or minimum 3, or you can take the mean value coming around 7. Okay. So for example, we have taken NG as 7. Okay. NG is the flashes per kilometers per year. Estimation of exposure is the probability of structure or building being struck by lightning in any 1 year is the product of the lightning flash density and the effective collection area of the structure. So lightning flash density that we have got. Okay, lightning flash density is the NG. Now next one is effective collection area of the structure. Effective collection area of the structure. Okay, so next one we have to find out is effective collection area. So the second step. So as I said, you have to take the annual thunderstorm days. From the annual thunderstorm days, you will get the mean values or the limits. So you can take any value between the particular limit, or you can take the mean value. So here we have taken the mean value, that is 7. Okay. So coming to next session, that is effective collection area. The effective collection area of a structure is the area on the plan of the structure extended in all directions to take account of its height. The edge of the effective collection area is displaced from the edge of the structure by an equal amount to the height of the structure at that point. Hence, for a simple rectangular building of length, width, and height in meters, the collection area has L plus 2 into H plus V. So finally, the equation is, effective collection area equation is length into width plus 2 into length into height plus 2 into width into height plus pi h square. So if I'm telling we are having a building with 30 meters length, 15-meter width, and 8-meter height, can you do the calculation for AC? Length is 30 meter, width is 15 meter, height is 6 meter. 30, 15, 6. Into, so I will take the word format 1 minute. Length into width, right? 30 into 15 plus 2 into 2 into length into height, that is 30 into 6. 30 into 6 plus 2 into width into height plus 2 into width into height, that is 2 into width is 15 into 6 plus pi h square plus 3.14, sorry, 3.14 into 6 square, 1009. Okay, 1009. Does anybody have different answer? AC equal to is there something wrong in the calculation? 1103. Fine. 1103. So we got the effective collection area and the lightning flashes per kilometer square per year. So NG, we got the value for NG and we got the value for AC. So what is the next step? Yeah, okay, fine. So here the probable number of strike to the structure per year is P equal to AC into Ng into 10 raised to minus 6. So we got the value for AC, we got the value for Ng, then you need to multiply it with 10 raised to minus 6. So please let me know the value for probable number of strikes to the structure. AC into Ng into 10 raised to minus 6. AC into Ng into 10 raised to minus 6. Ng is 7. That we have taken from the annual thunderstorm days, right? 7. From the annual thunderstorm days, we have taken the location as Cochin. So the annual thunderstorm days number was 63. So the mean value we have taken is, and from the table we got the value as 80. The nearby value is 80. From that we have taken the mean value. So Ng into AC into 10 raised to minus 4 is 5.4. Let me do the calculation. 1103 into 7. So do you mean the final value for probable number of strike is 5.4 or is 5.4 is something another value? Because the equation for probable number of strike is AC into Ng into 10 raised to minus 7. AC into Ng into 10 raised to, sorry, 10 raised to minus 6. AC into 10 Ng into 10 raised to minus 6. Please do that again. AC is 7. Sorry, what we got for AC 1103 and G7 into 10 raised to minus 6, right? 7.7 into 10 raised to minus 3. Fine. So 7.7 into 10 raised to minus 3. So P equal to AC to ng to 10 to the power minus 6. From that we got 7.7 to 10 raised to the power minus 3. Okay, fine. So we got the value for P also. So next we have to calculate overall assessment of risk. Okay, overall assessment of risk. So coming back to our standard, you can see overall assessment of risk. Okay, having established the value of P, the probable number of strike to the structure per year, next step is to apply the weighing factors. Okay, weighing factors in table 1 and 2. This is done by multiplying P by the appropriate factors to see whether the result, the overall weighing factors exceeds the acceptable risk of P equal to 10 raised to minus 5 per year. Okay, so we need to check whether it is exceeding the 10 raised to uh, minus 5 per year value. Okay, so what is the weighing factors? You can see weighing factors, table 1A to 1E. The weighing factors value are given under headings A to E, denoting as relative degree of importance of risk in each case. The tables are mostly self-explanatory, but it may be helpful to say something about the intention of table 1C. The effect of the value of the contents of structure is clear. The term consequential effects is intended to cover not only material risk of to goods and property, but also such aspects as the disruption of essential service of all kinds, particularly in hospitals. Okay, the risk to life is generally very small, but if a building is struck, the fire or panic can naturally result. All possible steps should therefore be taken to reduce the effects, especially among the children, the old and sick. So what is overall assessment of risk? So total weighing factor, we have to multiply all the weighing factors. So overall weighing factor A, what is overall weighing factor A? Use of structure. So can you select or can you suggest the type of building which we can use? If it is a hospital building, just assume it is a hospital building. So what will be the value for A? Weighing factor A, if it is a hospital building. Okay, fine. Weighing factor A. So you can see the last point, children's hospitals, children and other homes. You can see 1.7. So we got the value for A. Now we need to check the type of construction, weighing factor B. So can you suggest the type of construction for the hospital? Steel framed, reinforced concrete with any roof, steel framed, encased brick, plain concrete, timber framed, brick, plain concrete, masonry, any building with a thatched roof. I think in India, most of the hospital building will be like reinforced concrete, right? Reinforced concrete. So we can take the value 0.4, right? The roofing will be reinforced concrete. So we can take 0.4, right? Is that okay? Or do I have to select any other value? Please let me know your thoughts. Seems okay, fine. So we can select the type of construction, weighing factor B as 0.4. So now we have to go to the point contents or consequential effects. It is actually, they already mentioned it is actually equal to 1A, table 1A. So again, check the type of building. So we can understand what will be the consequential effects if lightning strike to that particular building. So ordinary domestic, industrial, power stations, industrial key plants. Again, finally, schools, hospitals. So we need to take which value? For the weighing factor C. So we got the value for A, B. So what is the value for weighing factor C? Okay, 1.7 again. So now we can go to the weighing factor D. Degree of isolation. Structure located in a large area of structures or trees of the same or greater height. For example, a large town or forest. Structure located in an area with a few other structures or trees of similar height. Structure completely isolated or exceeding at least twice the height of the surrounding structure of trees. Here I have taken the degree of isolation. We have taken the height only 6 meters, but even though, just consider it as a hospital, obviously which value we can take for the weighing factor D? First or second or third? Which one we can take? Don't imagine the height of the building. Just think we are doing a hospital project. So obviously, which value will be suitable? For the weighing factor D. Last one, yes, last one. Obviously, the hospital building will be the uh, highest building comparing to the surrounding building. Normally, normal case, if we are having an apartment building near to it, that one will be the tallest building. But I'm saying just take it generally in a city, and it is located and it is completely isolated, like from the surrounding buildings. Then obviously in the most cases you can take the value 2.0 for the weighing factor D. Structure completely isolated or exceeding at least twice the height of the surrounding structure or trees. So whenever you get the project, you need to check the nearby buildings. So yeah, if the nearby building is having more height, then you can rethink about the value for D. But here we can assume the structure is completely isolated or exceeding at least twice the height of the surrounding structure. So for the weighing factor D, the value is 2.0. 2. Okay, so coming to the type of country. So this you can suggest the value depending upon your assumption. Type of country. If it was my hometown, I would have taken flat country. That is 0.3. So depending on your area, you can suggest some values. Whichever value we are getting more opinion, we can select that value. Hill country, flat country, mountain country between 300 and 900 meter height, mountain country above 900 meters. So this 900 meters is actually considered as the height from the sea level. Okay. So suggest some value for weighing factor E. Which value I should take for the weighing factor E? Somebody say a value. 0.3, fine. So we got the value for A, B, C, D, E. Okay, fine. So overall assessment of risk. Overall assessment of risk equal to A into B into C. That is equal to A 1.7, B 0.4. 1.7 2.4 5.7 into 2 into 0.3. So what will be the total value? So what is the total value for overall assessment risk? 0.69. Fine. So this 0.69. Okay, fine. So next step is you have to calculate, you have to multiply the probable number of strikes and the overall assessment of risk. Probably is E is equal to ng into 10 raised to minus 6. And you have to multiply the overall assessment of risk with the that is E into overall assessment of risk. So what would be the value? 7.7 into 10 to the power minus 3 into 0.69. Please calculate the value. 5.35 into 10 to the power minus 3. Fine. So 5.35 10 to the power minus 3. So from this particular value, this is one digit number 5.35 5.35 into 10 raised to minus 3. So you have to check. The risk factor method put forward here is to be taken as the giving guidance on what might be in some case be a difficult problem. If the result obtained is considerably less than 10 raised to minus 5, then in the absence of other overriding considerations, protection does not appear necessary. Okay, but here we are having 10 to the power minus 3. Okay, our so how we actually identify whether protection is necessary or not? So here we got the single digit value, that is 5.35 and 10 to the minus 10 to the power minus 3. So if the value was lesser than 10 to the power minus 5, the protection is not necessary, like 10 to the minus 6, 10 to the minus 7. It was not necessary. But here we got the values 10 to the power minus 3. Okay, so here they have done a sample calculation. They got 3.4 into 10 to the power minus 3. Okay, hence the protection is necessary. So if you are getting single digit number, this is actually single 3, 4 up to 9, you can take the value. And if it is coming as 10, you can move the decimal to left hand side. So here the 10 to the power minus 3 or minus 4 value will be changed. So based on that, if you're getting 10 to the power minus 6, protection is not necessary. It is coming greater than minus 5, that is minus 4, minus 3, minus 2, then protection is necessary. That is the conclusion. After doing all this calculation, this is the final value we are getting, and based on the power, we need to check whether protection is necessary or not. So you might feel this is like, oh, why we are doing unnecessary calculation, and this is actually looking weird. This type of calculation looking weird. So it is actually depending on the client's requirement. Normally, client would be saying, yeah, lightning protection is important for him because this particular land or this particular building is prone to lightning. So he might be giving such information. And also, if even if you check the location surroundings, that particular building you are going to design might be the tallest building, then in any case you can give the protection, because no need to check the geographical conditions, lightning strikes and all we can expect at any time. Okay, so in that case we can provide the lightning protection system, but this is the procedure to calculate the lightning protection system requirement. Okay, so if lightning protection is required, if lightning protection is required, uh, what is the next step? So that we have already seen in the initial discussion. If protection is required based on the base area, that structural base area, we need to provide either one or two, like depending on the base area. So okay, so for example, we are having a building with base area 400 meters square. Base area equal to 400 square meter. So point is, structure having a base area not exceeding 100 meters square need to have only one down conductor. For structure having base area exceeding 100 meters square, the number of down conductors shall be smaller of the following. So you just need to take one plus additional one for each 300 meters square or part thereof in excess of first 100 meters square. So out of this 400 meters square, you need to reserve one for the first 100 meters square. So for remaining each 300 meters square, you need to provide an additional down conductor. So how many down conductors we would require for a 400 square meter base area building? Two. Okay, fine. So now I'm gonna take lightning protection. So total area of the building is 954.23 square meters. So how many down conductors we would require? Nine 54.23 meters square is the total area. So how many down conductors we would require? Total 4 numbers. Fine. You can see for the first 100 square meter, one down conductor would be required. Additional 300 square meter, one down conductor. So hence 954.23 minus 100 divided by 300. So 2.84, approximately say 3 numbers. So 3 plus 1, 4 numbers. So hence total 4 down conductors provided. So depending on the number of down conductors, you have to provide the earth pitch. So you have 4 down conductors. So how many earth pitch you should provide? And how you can represent that in a drawing? So obviously you will be having the roof plan with you when the client or the architect provide you the architectural plan. So you have to, and the elevation, you will be having the elevation also. So based on that drawing, you have to represent the lightning protection system concept drawing. Okay, so as I told, this will be handled by a separate lightning protection uh, contractors or team, but in the designing we have to provide the proposed location. So final location will be decided by themselves, but anyway we have to provide a proposed location considering all the remaining factors. Okay, then in that way you can just assume this one will be the location for, even if it is okay for the contractor, he will be providing the lightning protection down conductors and the air terminals and earthing system. So basically air terminal will be the down conductors. Based on the number of down conductors, you will be having individual earth pit. So here we can show you drawing. This is actually the roof plan. Okay, so this green line represented is the down conductor. So initially you have to route this all over the roof area. Okay, so that means you can see that it is running all over the surface of the roof, covering all the parts. Okay, you'll be having a air terminal here at the center or the side, like this one, like a spike. Okay, you'll be having an air terminal here. Okay, so this air terminal will have a dynasphere on the stick, like, or a spike. Okay, at the tip of the terminal. So this one will be the one who ionize the air in the surroundings. So whenever lightning strikes, this will get strike to the air terminal, thus connected to the down conductors, and it is actually insulated. So it is having a porcelain insulator between the down conductor and the building. So we have to make sure that down conductors are provided at equal intervals. Okay, then it is safely earthed to the earth pit. Normally we would provide a pipe earthing for the lightning arrestor. So this is the plan drawing. You can see it is covering all the parts, all the edges, corners, and it is taken down at frequent areas. Like here, we require 4 numbers, right? So you can see 1, 2, 3, 4. At each tower, this one is actually different towers. So for each tower, they have provided the down conductors. So this down conductor is actually going down to the earth pit, the lightning arrest earth pit, 40 mm dia, 2.5-meter long earth electrode. Down conductor as the standard, as per the standards, the down conductor 25 into 20 into 3, 20 into 3. So here they have provided 25 into 3 mm aluminum, and for the elevation you can see 25 into 3 mm aluminum porcelain insulators, which is at every 50 centimeters. So every 50 centimeter gap you have to provide. So this one will be actually done by the team, like from the lightning arrestor team. So they have to keep the safety harness and all to fix this lightning arrestor installations, so that we can make sure that this air lightning down conductor is not being in contact with the building. Okay, it is coming down, and from the test joining, then the pipe to the earth pit, it is 30 into 6 mm. Okay, so the minimum size was 32 into 6 mm. Below the grounding level, 32 into 6 mm strip shall be used. Okay, so this is how we represent the lightning protection system in an AutoCAD drawing. So whenever you receive a high-rise building, you need to uh, mention the number of down conductor, and based on the down conductor, the earth pit locations and the air terminal system. Okay, so the requirement for the lightning protection is actually based on the client's informations, not mandatory to do the calculation which we've seen right now. That is the normal procedure to do the lightning protection calculation. So if the building is located in isolated area, obviously 90% is the chance is to provide lightning protection. We cannot take risk. Okay, this lightning protection earthing system may be interconnected to the normal earthing that we provide based on the HT set calculation, but it is better to island or not to connect all this earthing to the normal earthing system, like the separate lightning arrestor thing can be provided separately. Okay, no need to interconnect, but you can interconnect if you want. You can interconnect, not an issue. Thus, you can reduce the overall grid resistance. Okay, so I hope it is clear. But as I said, if you provide lightning protection for the building, it is actually only protecting the lightning or lightning strikes coming to your building. Okay, you cannot give protection to the equipments inside the building since it is vulnerable for the surge current coming through the electrical lines, electrical cables. So for that, we have to provide surge protective devices. Okay, surge protective device. So whenever you do project, you can recommend both the surge protective device and lightning arrestors. Okay, is that clear? So surge protective device, I can show you some catalogs on it. So we have type 1 surge protective device and type 2 surge protective device. Does anybody have an idea which one we will be providing for the residential building? Type 1 or type 2? Just uh, let me know your thoughts. Yeah, for transformer, that is separate one. For transformer, that is separate one to protect the transformer alone. Okay, that one is only for the transformer alone. Okay, this one I was saying about the building, total building. Okay, so we will be providing lightning arrestor protection, and lightning protection will be there for the transformer also, and the surge protection also will be there. Okay, the methods will be different. The connecting devices and the physical appearance will be different for the transformers surge protective devices. This one I was telling about the lightning protection for a building, so that the building is completely getting protection from the lightning strikes. But coming to the surge current inside a building, how we can surge, we can get the surge current to the building. I will show a picture. 1 minute. So this one is our building. Sorry, this one is our building. So you have provided the lightning arrestor, and this one is safely earth to the pit. So whenever lightning strike to your building, this one will the dinosphere and it will be safely. So nothing will happen to your building. So in that way, you can directly protect your building from that. Means you can protect your equipments from direct lightning strikes. Okay, since your whole building is being protected from the lightning strikes. But in another way, I can say you're feeding the electrical panel. So your electrical panel is located here. Okay, so to the electrical panel, you're taking either UG cable or overhead line. Okay, so from where we are taking nearby electrical utility pole, something like that. Okay, so from the electrical, lightning strikes here, this particular point, this electrical line will carry the surge current to your building. Okay, so indirectly you're getting the surge current to the building. Okay, not from direct lightning strikes, but from the nearby utility pole. So this can carry the lightning within a short duration, like 3 seconds, 1 second. So if you're, even though if your building equipments are not turned on, this may cause the arcing current. So if it is not connected, even though if it is isolated, there's a chance to get the surge current to the equipments connected. So if this equipment is turned off, even though it is connected and it is turned off, this contact might be enough for the arcing current to pass to the building and thus damaging the equipment, especially low voltage devices. Okay, so to make sure that we are getting equal protection from the surge current and the lightning protection, we have to provide lightning protection system, and at the panel incomer or the DB incomer, we have to provide a surge protective device. Okay, is that clear? For transformer located in the building outside the outdoor area, we'll be having another surge protect device parallelly connected. This will earth the lightning current, etc. Everything. Okay, so this one was the building. Okay, so here this application is different. This is surge protective device appearance, physical appearance would be different. This one also, this one will be a compact one. Okay, so asking which type, just let me know from seeing. You can see type 1 and type 2. Which one will be suitable for the building? Type 2. Why you have said type 2? Is there any reason, or you simply said type 2? So what will be the use for type 1? Okay, I will explain. So type 1 is actually used for individual electrical equipments which can, there is a chance to get the surge current, especially high powered industrial devices like that, something like that. Okay, so type 2 is actually for the particular distribution board. So if you take type 2, you can see different types: 65 kiloampere, single pole, 2 pole, 4 pole. So and the price is listed here, the MRP price is listed here. Okay, so you're providing 65 kiloampere, and you can have another option also, that is 40 kiloampere. Okay, so what does that single 65 kiloampere means? So each pole you would be having 10 kiloampere each, so 10 or 15. Okay, so each pole you will be having 15 kiloamperes, and the overall protection rating is 65 kiloampere. So whenever a lightning strike, there is a chance to uh, pass around 10,000 amperes from a single lightning. Okay, so whenever we place this surge protect device parallelly, for example, we're having the dB, and dB incomer from the source, that is national grid. Here we will be providing the surge protected device parallel connection, and this one will be earth. Okay, so whenever there is incoming surge current, this will detect the surge current and it will bypass surge current safely. So this surge protected device will be having some cartridges inside the equipment. So normally this cartridge will be in green color. Okay, green color. Whenever lightning strike, the color changes. The capacity is getting reduced. So whenever the color get close to the red color value, you have to change the cartridge. Now you need to change the entire device. You can change the cartridge, individual cartridge, based on the colors and the value mentioned. So there will be like they will be mentioning the time of change when we need to change the cartridge. So if you are prone to lightning, if your building is prone to lightning, it is better to, it is not so costly when you are constructing a new residential building, just like only 28,000 Indian rupees coming to the 4 pole surge protected device. And normally we always recommend surge protected device for the newly constructed building, residential building. Okay, so it is actually, as per the standards, it is not mandatory, but for the safety, it is actually recommended. Okay, so taking the such protective devices, I can show you some picture in a minute. So it is actually compact in size. So you can even insert, or you can even place it inside the distribution board if you have sufficient space, or else you can provide a separate provision for providing the surge protective devices. Okay, so this is the cartridge color. It is not that much visible. Mechanical green color indicating healthy SPD surge protective device. Mechanical red color indicating end of life. Okay, this is the cartridge color. So depending on the cartridge color, you have to replace the cartridges. Okay. Yeah, for the you need to provide separate earthing for the surge protective device. You can't connect it to the nearby earth pits you have already provided. You have to provide separate earth pit, separate earthing for the surge protective device. And one more thing, if you are providing surge protective device, so just imagine this is your house. Okay, so here you have the electricity utility pole. This is electrical pole, and you are taking. So here you have the energy meter. Okay, you have provision for the energy meter. Okay, so you might be thinking like, if you provide the surge protective device with the incomer of the energy meter, then it would be better. Like every area will be safe inside the building. Okay, please show the SLD for lightning arrestor CC. Lightning arrestor, you don't have SLD. You can show it in the elevation drawing, because lightning arrestor is a separate thing for the building. Okay, no need to mention it in the SLD single line diagram. But for the elevation, I can show elevation drawing. If you have already seen, right? I can show that again. 1 minute. So if the energy meter to the main panel, you're taking it underground, and the distance is crossing 30 or 40 meter, just some value like that, you need to again provide a surge protective device here. There is a chance for the lightning to pass in case if you are getting strike somewhere like this. Okay, so if it is underground, that is not an issue actually, but you have to provide if the main panel and energy meters distance is crossing a particular limit. Okay, so obviously if it is inside the building, not an issue. If it is inside the building, you already have lightning protection for the building, and you have already provided the a surge protective device at the incomer of your main DB. Okay, so it is better to provide surge protective device at the MDB, not at the energy meter, if this particular cable is going outside the building. Okay, so coming back to lightning protection. So this is actually the building. Okay, separate earthing wire will go to the DB. From where you are asking, separate earthing wire will go to DB. Obviously, the DB will be having separate earthing. Yeah, for surge protected device connected parallel to the incomer, this surge protected device will be go to the separate earthing. Okay, so coming to the lightning protection, this is actually a single building. Okay, this is another building. Fine. So this one needs, if this is your project and you are doing this single, just ignore the right side building. Okay, this is your building, and you are having a lightning air terminal here. Okay, this is the air terminal, and this air terminal will be having dynasphere over the tip of the lightning arrestor rod, and this is actually connected to the down conductors. So this down conductors has to be brought down. So how many down conductors you need? It is actually based on the total area. Okay, so you have four numbers. So that is why we have provided four numbers at each towers. One here, two, three, four. So this is bring down using the 28.5 into 3 mm copper or GI strips. And after reaching the test link, from here, the size is actually changed to 38 into 6 mm. So minimum it should be 32 into 6 mm. So this is actually separate one, not being connected to our any earthing, any electrical panels or something like that. So no need to provide a single line diagram for a what we say lightning protection system. So I can represent this would be like this. So just imagine this is a lightning strike. We have a dynasphere here. We have the rod connected to the building. So this is a building surface. From here, down conductors are being isolated using the porcelain isolators. It is bringing down. So you should not get any contact with the building. Okay, you have to make sure that it is actually going to the other side. This is a representation, so simple. Okay, I hope it is clear. And the part for the surge protection. I have already uploaded this drawing in the reference drawing section, so you can refer this drawing for the lightning protection part. So you have to provide the drawing based on the standards. This is actually based on the Indian standards. Yeah. And the standards related to lightning protection system is mentioned in the high-rise building section point 27 and 28. And the calculation for the requirement, it is taken from the IS 2309. IS 2309. Okay. Coming to the next topic, CCTV system. So this actually comes under the low voltage part. Okay. So again, for this, the execution will be done by a separate team. Okay, and also they will be providing a separate drawing also. But at the initial stage, for while doing like we will be preparing the electrical drawings, right? Like concept drawing, design drawing. So along with that, you need to provide the access control drawing, CCTV drawing, communication drawing, etc. Okay. So regarding like considering the building, okay, based on the building, nowadays every building have the CCTV system, surveillance system. Okay. So do you think normally some people think that when you provide CCTV system, all the security system has been tightened, like all has been completed. It's not like that. This CCTV system is actually for the surveillance only. We can see what all things have happened from the locations, from the camera locations, and the things being done under the range of that camera. Only we can understand or we can find what all things happen. It does not give security or safety. Okay, so safety or security system, you need to provide additional features, okay, which can be integrated with CCTV system, or you can provide another methods like perimeter security system. We don't think that regarding the safety or security, if you provide the CCTV system, it has been completed. No, it is not like that. You have to provide additional features like sensors you can provide in the main doors and all. nowadays people does not provide normal sensors, because whenever some people come or some animal is passing by or something come to the sensor area, this could trigger the alarm. So nowadays artificial intelligence methods are being chosen by the clients. So perimeter security system is one of the method. Okay, so coming to the point, CCTV system is actually for the surveillance. Okay, so what all components we need to uh, think about providing locations, like for example the main part is camera, right? You have to provide the location for camera. So still I'm saying that, like, even if you provide the location for the camera, one CCTV expert will be visiting the site and he will be recommending the exact location. But we also should have some idea about this CCTV part. Okay, like the range of cameras, type of cameras. It is not a big task to understand the CCTVs. Like, you need to understand the camera types, the connection procedures, location for the monitors, monitoring system, and the recording. Okay, so just imagine you're taking a residential building. Okay, so obviously for a residential building we will be providing only outdoor cameras, right? For a normal client would be thinking like that, like we will be providing outdoor cameras. Outdoor camera means you will be, the most important part to be covered is actually the outdoor area. No need to cover because it will become like to be utilizing the personal space. So mostly the client would be thinking to provide to outdoor area only, like the compound wall, the car parking area. If there is a generator, you have to surveillance the generator. If there is a entry or exit point, you have to monitor the entry or exit point. If there is a chance, if the person can cross the compound wall, so you need to cover all the area. There should be no blind spot, providing the CCTV drawing. Okay, so I can just show a drawing that we have provided for a client. Based on that we can discuss. Okay, we have recommended a location for the cameras, for individual cameras. Type of cameras are also mentioned. So I can show you this drawing in a AutoCAD file so that you can understand clearly. But I just want to show what all things we need to represent in the drawing. Location of cameras and the NVR. So what is actually the full form for CCTV? What is the full form of CCTV? Yes, closed circuit television. That is the full form of CCTV. Okay. So CCTV is the use of video cameras to transmit a signal to a specific place on a limited set of monitors. It differs from broadcast televisions in that signal is openly transmitted through it may employ point to multi-point or meshed wireless networks. Okay, so you'll be having a set of cameras, communication cables, and the DVR or NVR, so in the monitoring unit. Okay, so uh, you need to understand the type of cameras initially. Okay, so uh, anybody have an idea which type of camera will be suitable, or what we say, for high security areas, like a military purpose or a defense purpose. You need to provide type of cameras, right? I just want to know whether you have an idea about the different types of camera. Anyway, we'll be discussing the type of cameras, but I just want you to know that whether you have an idea about this type of camera that being used in different applications. So which type of camera you'll be using? You can say anything, like what whatever coming to your mind, like which type of camera you'll be using for a high security provision area, like defense or military purpose. Dome cameras. Yes. Have you heard about PT set cameras? PT set. PT set. No. Okay. So there is one type of camera known as PT set. The full form is pan, tilt, zoom. Okay. You might have seen that in different movies or different areas which have you visited. Like you must have seen that type of camera. The only thing is like it looks like dome camera, but it have a wide range of what we say, can pan the camera and tilt the camera and zoom it according to the specification. Okay, I can just show a equation camera. And also, can you name any two of the brands who manufactures the camera, CCTV camera? Any two? Have you heard about Hikvision? Hikvision. Honeywell also manufactures CCTV camera. Honeywell, CP Plus, Bosch. Okay, so anyway, I can show you the range of PTZ camera. Okay, fine. I can just show the range of PTZ camera, so that you can understand what will be the use. So this is actually panning and tilting of the camera. You can see it is tilting, and you can pan the camera. See, and this one is actually having 36 into zoom, 36 into super zoom equation. Okay, you can see how much clarity you are getting and all the details you are getting. See, so this one is known as PT set cameras. So the minimum cost will be around like in Indian rupees, you can say 30,000, depending upon the range and the zooming function. Okay, and the pixel. So obviously this will be used by the high security areas. You can see the range. I think you understand the range of these cameras, right? You can pan, tilt, and zoom. See how much clearly you are able to see the building opposite to the lights from 100 meter to 100 meter. Okay, fine. So this one is the PT set camera. Okay. So what shall be the specifications of camera that we need to understand for a bullet or a dome camera? So what is dome camera? I'll show that. Before that, we need to understand why use CCTV. It is caution to prevent and deter crime, foolproof coverage, reduce property insurance premium. These are the importance of providing CCTV. Okay, not so important elements of CCTV: camera, lens, monitor unit, DVR and NVR, storage device, DC power supply. Obviously, as I said, this comes under the low voltage supply. So your camera works in DC supply, 12 volt supply. Okay, so these are the elements that is coming under the CCTV system. You need to specify the camera. So as I said, you have to select the type of camera, the focal length of camera, the range of camera, and finally, as I said, all these are included in the type. Range is actually mentioned in the length. If it is not pan tilt zoom type, pan tilt will be having the zooming dimensions like 30x or 20x, 20 times, something like that, and the pixels, range, focal length. Okay, so and also the budget. When you see the drawing, you can mention this drawing. You can provide like when the range of area you will be having from the site plan or the whatever the plan. Okay, so you have a architectural plan with you. So while observing the plan, you knew this camera will be suitable for this particular area, means dome or bullet, based on the application and the range you can provide. And you can also mention it in the drawing itself. So this will be covering this much area if you provided at an angle of this position. Okay, and the practical condition could be little bit different from the drawing we have provided. Okay, so CCTV camera types. CCTVs are being installed everywhere for the purpose of security and crime prevention and detection. There are many types of CCTV cameras available: indoor camera, outdoor camera, IRD or night camera, dome camera, bullet, vandal proof camera, hidden camera, pan tilt zoom camera. Okay, yes. Pan tilt zoom. Okay. Pan tilt zoom camera. Okay, so we have different types of CCTV cameras. So based on the application, you have to select one among the following. Okay, so obviously for indoor purpose, we'll be selecting either dome or bullet type camera. So it actually depends upon the location of that camera being that we can provide. If you're having a proper sufficient ceiling space to provide camera, most probably you'd be choosing the dome cameras. So dome cameras are recommended for the ceiling locations. Okay, if you have proper wall area and that it is having protection from the weather conditions, so you can provide a wall mounted weatherproof bullet cameras or that cylindrical type cameras. Okay, so depending upon the location and the application, you can select the type of camera. Okay, so this one is outdoor camera. Outdoor camera is used for outdoor places. They are mostly used for entry and exit with a limited night light. This camera have hard shell vandal-proof casing. And dome cameras. So dome cameras are installed inside dark dome, are designed in a way that go unnoticed by visitors. These cameras can be rotated and tilted manually. So you can rotate this camera's angle of view and adjust the tiltable like to upward and downward. Okay, so this one will be having like camera specification. In that you can see the focal length and the angle of view. Most probably most cameras have a angle view of 80 degree. Okay, so from the point of view, just take the 80-degree viewpoint, then you can understand the coverage area of this camera. Okay, and the focal length. So whenever you might have noticed in the monitoring displays, you can see the person who is actually standing in the building and it is being covered in the camera is looking very close in the video. Okay, in the video I'm saying, because the focal length of the camera might be different. Okay, our focal length, normal focal length is like a 25 centimeter. Okay, for the normal reading, I'm telling about the normal reading. But the camera's lens, like even in the convex mirrors used in our motorbikes, you can see objects in the mirror are closer than they appear. Okay, that is actually a different, it is having a different focal length. So depending upon the coverage also, you can select the focal length. So if you uh, take the lens with higher focal length, that means it is like actually zoomed to the point of view. Okay, so focal length is important, type of camera, the megapixel. Okay, you know the importance of the megapixel. I don't want to explain that. Like the pixels form, the number of pixels form that particular video or the picture. So based on the pixel, the clarity will be high. Okay, so basically we have different cameras based on the application and functions. So uh, show the drawing. Okay, so this is actually a CCTV drawing that we have provided for a client. So what do you think? Which part of this building will be having blind spot area? This is actually the range, coverage range. Okay, and this magenta line is actually the length of the means the total range which the camera can cover up to this area. Okay, and the coverage will be like this. We say, for example, it will be like this. It will be covering this much area. This much area can be covered by using this particular camera alone. So is there any blind spot coming in this particular drawing? Can you say any blind spot coming? Just say left top, left down, right top, or right down. You can say outside the building. Is there any? This is actually the compound. Okay, this line is actually the compound. This one. This is the residential building. It's the compound. So this is actually a road. Okay, so this is actually the entrance here. The entrance will be here. We have provided a number plate recognition camera also towards the road. Okay. So is there any blind spot here? Even if it is a small portion, you can say top left with blind spot. Yes, right. That is right. Here, this part will be acting as the blind spot because this camera's angle of view is having 80-degree, but it will come and hit this particular area. So this area, this particular area, will be acting as blind spot. So what is the solution that we can uh, remove it from the blind spot? How you can add a additional camera where you can add either on this particular wall or you can add it in the compound wall. When the compound wall being constructed, you can provide it here. So all the remaining areas are actually being covered, right? So this is how we make sure that all areas is being covered from the uh, perspective of preparing the drawing. Okay, while visiting the site, your thought will be changing. Obviously you will be uh, revising the drawing based on your site visit and all, but while seeing the initial drawing, you need to understand the camera range. So this is actually represented for the camera length from the point of view. Okay, this line. Okay, and also you can provide it in another way. Coverage angles is 80-degree, 80-degree view. Coverage angle means the camera's view. If you provide that camera, whatever things coming in front of the that particular camera, it have a coverage angle. You might have seen uh, fish eye cameras. Fish eye cameras means it will have almost 130-degree coverage, and also the dash cam we provide it in the cars, that can also have 130-degree view, because when providing the dash cam we have to get the views from the right and left side also. Then only it will be beneficial. If you're having a 90-degree or 80-degree angle of view in the dash camera, only you can see, you can record only the whatever things coming in directly in front of the camera. If you provide a fisheye camera or a camera with an angle of 130-degree, you will be getting the left and right hand side view also. This camera we have selected is 80-degree coverage. That is why we have drawn the angle of view like this, which means this particular area you will not be getting any visuals, but this will be covered using this camera. And we have another drawing also which the full coverage expanded. Let me check whether I'm having that 1 minute. One minute. So in this way also you can represent a drawing. So this hatch area is actually being covered in the full range. So easily you can understand the blind spot area. This one will be a blind spot area. This one might be a blind spot area, but not an issue, because to a person can enter this area has to pass through the surveillance part. This one will be, this one also might be a blind spot area, but that one also not an issue. This is like an islanded portion. Okay. Length of vision, that one also depending upon the type of camera. So that regarding that I can show you. I'm just taking a catalog. Okay. CP plus. You might have heard about CP plus cameras. So I'm taking the website of CP plus. Okay. Products. Network camera. So I'm just selecting 5 megapixel camera. Okay. Oh, 6 megapixel. So I'm selecting 6 megapixel camera. So you can see 6 megapixel camera, full HD, WDR, IR network, bullet camera. This is a range 40 meter. Okay. Is that clear? The range of camera, the length of vision. This is the length of vision. Okay, 40 meters. So whenever you provide the camera from the tip of the view to that 40 meter, but 40 meter camera will be very costly. If it is necessary, you can provide. Okay. So here we have provided 20 meter cameras only. DLI. Sorry, DLI from the tip of point. 20 or 30 meter might be. Yeah, 20 meter only, 19.73. So we have provided 20 meters camera. The range is 20 meter. So depending upon the number of camera, if you want to reduce the number of camera, and depending upon the site conditions, you can take 40 meter camera. Okay. So this one is having 6 megapixel image sensor, 20 frame per second. So I think this one also you might be knowing the frame per second. So even in your smartphone, you can have multiple options for the frame per second, 20 frame per second, 40 frame per second. So depending upon the frame per seconds, the storage file size will be different. Okay. The advantages of digital cameras are like you have option for the cloud storage. Okay, you can buy the cloud storage and this can be directly uploaded to the cloud. So which will be having more capacity. So normally you can select camera, next one will be the storage device. So we call it as NVR. So what is the full form for NVR? Anybody know the full form for NVR? NVR. NVR is actually network video recorder. Okay, network video recorder. Inside the NVR, you'll be having hard disk. Okay, this hard disk will be having a storage of nowadays we take minimum is 1 TB. Okay, or 2 TB. Okay, so depending upon the camera's features, you can set the how you can record the file, because some cameras will be always recording the visuals. Okay, in that case, the storage size will be rewritten in every week. Okay, you can give another option, only record when there is a movement. In some particular cameras, you can provide an option, only record when there is a movement. For example, you have provided an outdoor camera, and this outdoor camera is having some trees or leaves in front of this particular camera. So obviously, whenever there is a movement, this camera will be recording all the visuals. But if you are providing an indoor camera, if everything is still, it will not be recording. Only live monitoring will be there. Okay. Thus, you can save the storage with unnecessary visuals. So that depends on the type of camera you are using. And obviously, when you're providing a bullet camera, you need to understand it should be having IP ratings. So you can see IP67. So does anybody remember the physical and water protection for IP67? If you remember, just recollect it. IP67. What is this physical and water protection for IP67? What does that mean? IP67 means waterproof and dustproof. Yes. So it have waterproof and dustproof protection, that is IP67. So you can provide this camera outdoor. Okay. And this one is having visuals of around 2688 into 1520. What does that mean? 2688 into 1520. The resolution, right? So you're getting almost 2K resolution from this camera. Okay. And day or night, 3D NR, AWP, ADC, BFC connectors. Okay. 2.8 mm fixed lens, 3 mm optional. Okay, so the lens is having the focal length of 2.8 mm, IR range of 40 meter, micro SD, mobile software, CMS software, and you can go with the detailed of specification. 0.04 lux you're getting from the minimum illumination you require is 0.04 lux. So you'll be having internal LED lights within the camera, effective pixels. Okay, body type bullet, auto or manual, shutter speed 1/3. Auto or natural speed, lens 2.8 mm, gain control auto or manual, video comparison, aspect ratio more than 50, backlight, video streaming 6 megapixel 1 to 20 fps, 4 megapixel 1 to 25-30. Resolutions are also provided. Motion detection, yes, off or on. So that is why I haven't mentioned that motion detection, privacy mask, ICR, Ethernet, RJ45, user account 20 users, 40 operating time, power consumption less than 6.5 watts, weight. So everything is mentioned here. So you can see another type of camera, same 6 megapixel camera. This one is dome type, right? It is having 50-meter range. Uh, 6 MP camera, 20 frames per second. So here they haven't mentioned about the angle of view. Okay, in some catalog they might be mentioning. So to get the angle of view, you might need to get in touch with the technical team, or else you can assume the minimum angle of view as 80 degree. Okay, they haven't mentioned any of the angle of view in the catalog. 3 megapixel camera can take 3 megapixel, 50 meter, 50 meter, 50 meter, show all, 50 meter, 50 meter, 30 meter. So initially we would be able to connect only maximum 60 number of cameras to a particular DVR or NVR. So nowadays we can connect up to more than 100 cameras in a single NVR. Okay, so depending upon the camera numbers, you will be having, or the location, you'll be having multiple NVR or DVR, and the type of cameras you have to select. So normally we use Cat6 cables for interconnecting the cameras and the NVR. So this Cat6 cable have the provision to provide the power supply as well as the communication. Okay, otherwise we have to provide separate power supply cable and separate communication. So one, uh, I cannot say it is a disadvantage. One thing you have to understand is, for each camera you need to take individual Cat6 cables from the NVR, individual Cat6 cable. Okay, so regarding the NVR, you can see the speed dome camera also mentioned here. The uh, dome cameras, 2 megapixel 100 meter, 4 megapixel 100 meter, 150 meter, 200 meter. Price might be more than 100,000 rupees. Check the same specification. This is not the actual price. Okay, 4,000. Take Amazon, not available. Okay. Anyway, it would be good if you know the pricing also. Then only you can suggest the correct cameras according to the budget. 240 per 240 degree per second pan speed, 30 360 degree and less pan rotation. Coming to the NPR, you can see 4 channel, 8 channel, 9 channel. The channel means the number of camera that can be connected to the particular NVR. Okay, so if you take 8 channel, that means you can connect maximum 8 cameras. So for each 8 cameras, you have 8 Cat6 cable. 8 channel 4K video network recorder, 8 channel 4K 8 PoE. So when you do the design for CCTV, the most important thing you have to make sure that NVR should be in a highly protected area, because normally when thieves are entering the buildings, they know nowadays every building have cameras. So what they do is they'll be taking the NVR along with them. Okay, so make sure that NVR is not provided in a common area. You can provide in a master bedroom or some area like showrooms or something like that, with safety. Okay, with more safety, so that even who the person is trespassing your area, he will not be able to find the NVR location. Then it will be good. Okay, so you need to understand, like you can't provide it in a public, like common space. So depending on the number of camera, you have to select the appropriate specification. So up to 128 channel is available. That means even if you're having around 100 cameras, you can connect within the single NVR. If you go to the DVR, let us see the DVR. What all option here? Maximum 32 channel is the option. So for the DVR, you can have is the maximum 32 channel. So nowadays everyone is going for the NVR type only. Analog or digital video recorder is actually being outdated. Okay. You can see accessories. When it is connected with cell phone, NVR is required or previously. Obviously, DVR will be having lesser cost comparing to the NVR. And what we need is actually for this DVR, they will be providing a software. So you can install it in your phone. Only thing, you should have a internet supply in your connection to the DVR. So you can access the visuals from anywhere. So in that case, NVR is not mandatory. Okay. NVR have more advantages. The cameras are all digital type. They have cloud storage, visuals clarity will be high. What we say, file size would be different. Okay, that is the main difference. Like for NVR and DVR, one is analog and one is digital. You can have Wi-Fi cameras. Means wireless cameras. So camera catches cables. This one actually can provide both the power supply and the communication line. If more cameras is connected, say more than 300, you need, obviously you would need multiple NVRs, and this multiple NVRs can be integrated to a common point, that is like a monitor. So that monitor, from that monitor you can view visuals from the individual NVRs. Obviously for a 300 number of camera you cannot provide with a single NVR, so you'll be having n number of NVRs. Also depending on the location, if you're having uh, length around 100 and 150 meter or 200 meter, it will also affect the uh, what we say, the signal strength. So in that way we'll be providing multiple NVR depending on the building location. You're having a larger compound and you are having different buildings at different locations, so it is better to provide individual NVR for that building itself. If you're providing a single NVR and you're connecting it through the underground or overhead line with more than 200 meters length, signal, it will be affecting the signal strength. But in digital camera you can provide a network switch and you can adjust the signal strength, even though it would be better if you provide different or multiple NVRs. No need to provide power supply for each camera. You can provide in that way also, but the NVR have an option to pass the power supply through the Cat6 cable. Normally for DVR, we don't have that option. We have to provide an SMPS. Okay, switched mode power supply. So from the switched mode power supply, you would provide 12-volt supply to the cameras. So we were using RJ59 cables for the cables. I can show that RJ59 cables 1 minute for DVRs. Okay. This is RG59 cameras. Okay, so power supply you will be having a red and black, and this is the communication line. So at the tip of the camera and the NVR, this will be separated. Okay, so this plus and minus will be having a separate jack, and this communication will be separate jack. At the camera, we will have an option to connect this communication line using a BNC connector, and this will be also having a separate connector. At the end of the SMPS and DVR, this will be directly going to the DVR port, and this will be going to the sorry, I have paused the screen, right? Sorry. Okay, you can see this is a RG59 cable. So this one is has the communication port. This one is the power supply. Okay, this one is actually being used for the DVR, not NVR. NVR we can use the Cat6 cable. Okay, Cat6 cable also have the specification to carry the power supply and what we say communication. So this one also same, but here you can see this one is actually separated. So this one is actually being used for the communication. This one for the power supply. Okay, plus or minus. Okay, at the end of camera we'll be having a separate provision. Okay, to connect. There's a BNC connector known as a BNC connector. Okay, and this one also have a separate connector to connect the plus or minus power supply. At the end of another another part, that is the end part, like we'll be having SMBS or DVR here. So this one will directly go to the DVR port. Okay, this one will go to the SMBS. So this at the end you have to make it separate. Okay, anyway I will send you a YouTube link explaining all the installation procedures. You will understand how to install and how this is connected. Okay, I can send you when I send the required class along with the mail. I will be sending the installation part. Okay, so another question was maximum length. Is it is better to get good visuals up to 100 meter. If the length is more than 100 meter, the signal loss will be there. You can maintain by providing a network switch or something like that. You can overcome that. But for the normal case, if the length is more than 100 meter, it would affect the signal strength. Let me see whether any installation videos are available on it. But even if you view this video, you will not be getting the audio. So anyway, I will be sharing this particular video so you can understand how this camera is being connected to the NVR and how they are getting the power supply and how it is being connected to the monitor. So that part will be clear. Okay. So back supports camera sensitivity, microphone sound. It's actually the backside port of the DVR or NVR. Okay. But here you can see this is actually DVR. Okay, this is actually for the communication port. This is not a network switch or PoE. So whenever you see NVR, you can see a PoE port. That is actually power supply over Ethernet. Okay, PoE. This one is actually the communication port only. For the power supply, you need to take separate SMBS here, which will be placed very close to the NVR. And at the end of this part, you have to separate the RG59 cable. That particular communication cable will be going to the port of the DVR, and the power supply will be going to the backside of the SMBS. So this one is actually the NVR. You can see PoE port. Okay, so this one can carry the power supply through the particular CAT6 cable. Okay, so no need to provide separate power supply. So that is one of the main advantage in NVR. So for what we say, for the normal DVR camera, this would be the port to connect BNC. So for Ethernet, like NVR and all, we'll be using RJ45 jacks for the CAT6 cables. Okay. And as you said, storage device, we'll be having nowadays normally used to select a 2 TB hard disk for the cameras. So most important part is like we need to understand while tracing an RFI, we need to think about the requirement of cameras. So whenever you prepare the concept drawing, you need to provide the CCTV drawings also. So you must understand the location for CCTV. Then you need to provide additional power socket, 6 ampere or 10 ampere sockets for the monitors and the NVR or DVR. And also you need to think about the routing. So whether this position, if you're providing NVR at this particular location, how you can route the CCTV wires. So while preparing the conduit drawing also, you need to submit the separate conduit drawing for the CCTV. You cannot take the camera CAT6 wires along with the electrical wires. Maximum for through a 20 mm pipe, you can take maximum 3 number of CAT6 wire. Okay, maximum 3 numbers. And as I said, for each camera, you need separate CAT6 cables. You cannot take it as a loop format. You need to take it individually. Here you can see we have provided the location for NVR in the master bedroom. Okay, this is actually the representation only, not the routing. Okay, this is actually the representation. Connection of camera is coming to the NVR. The conduit we have to provide separate drawing like this way. Okay, so this is actually the representation of cameras, type of cameras, outdoor cameras, range, the location of NVR, and while preparing the BOQ, you need to give a estimated quantity for the specifications of camera, the length of CAT6 cables, and the type of camera. Then when you prepare the quantity, the client can directly take the proposal from the dealer or the contractor. Okay, so you need to mention the specification of cameras, the range, the angle of view. You can directly copy that from the any manufacturer's website, or you can directly mention the brand also, either this or this CP Plus, Equation, or Honeywell. And NVR also, you need to mention the channels. That would be enough. And the specification you can copy from the website. You need to understand. You need to understand what is the difference. For that, you can directly contact the technical person from the particular company. So you will explain that to you. Okay, for understanding the difference. Even if you go through the specification, you might not be able to understand the what are the different actual difference. But when you contact the technical guy, he will be helping like these are the difference. This will be suitable for this building, so that you can select appropriate camera. And even after giving this quantity and details, as I said, the execution team will be coming to the site, and they will be cross-checking all the position, and they might be what we say, relocate the cameras. Okay, based on their experience and based on their knowledge, they will be changing. Only thing we can give a proposal, we can give the material quantity based, so that the client can understand what all budget will be coming for the CCTV installation. So along with this, we need to provide the security solutions also. That is, this one is actually cannot be considered as a security system. This is only a surveillance system. Okay, when a person is coming and entering, it will not give alarm. But nowadays we have an artificial intelligence softwares with the cameras, so you can program the software such a way that whenever a person is passing in front of this camera, and if the particular person's temperature or the body mapping is not they're in the database. In that case, that particular software will give you an information to your mobile phone, which you have the same software installed. So you will get an alarm. A new person has come to your building, which is not there in the database, because daily newspaper boy will be coming, some people will be coming. In that case, if it is normal census, you'll be getting a false alarm daily, and gradually you'll be ignoring the alarm. But in this particular software, they can program. Normally that software was actually being used in supermarkets to understand a person who is spending, in which category he is spending more time, to understand that. For the business marketing and all, they are using the softwares actually. But that can be integrated with the home security systems also. That means the cameras can track the movement of people and understand whether two people are fighting or two people are normally talking, based on their body language. Okay. And automatically that can give a call to the nearby police station based on the settings. Okay, based on the settings. So that is actually coming as the additional features. No CCTV manufacturers have that specification. That is actually third-party program which can be integrated with the CCTV cameras. But the same thing can be done by the perimeter security system. So the perimeter security system will be having different sensors. So the sensors can detect the human body temperature, the type of people in their database, and if someone is crossing the signal, someone is passing without the permission or something like that, it will give an alarm, and automatically it will give call to the nearby police station. So that is also another feature. Okay. So I hope the CCTV part is clear, and anyway I will show another part of drawing and the installation methods, so that you can understand clearly regarding the CCTV, and also sample bill of quantity or bill of material I can show regarding the CCTVs. You need to mention the cameras specification in detail and the NVR CAT6 cable. And the location of NVR is very important, and you have to provide a rack also. So you need to understand, you cannot directly mount this NVR on a wall. You need a rack system. Okay, which will be having the CCTVs, and all the CAT6 wires are coming behind this particular NVR. So you need to get proper access, and you need to it should not look ugly also. So since this is a master bedroom, you have to consider, like, thinking from the interior part of view also, you have to think. But the client said this would be suitable, that is why we have provided the NVR inside the master bedroom. Okay. So along with the today's recorded class, I'll be sending the installation video for the CCTV, so that you can understand clearly what all things will be there for connecting CCTV. I think let me search whether I can find DVR installation also, so that you can understand the difference between NVR and DVRs. Okay. So we can wind up today's session. We can continue tomorrow. Okay. Thank you.